Action.
Cool. Okay, so pendulum experiment. First I want to talk about how it's set up really quickly, because the longer the video, the harder it is to pay attention for longer. We've got our pendulum, we've got our length here, which is what we'll be adjusting. Two blocks at the top compressing the string of the pendulum, and I'll just be adjusting it by loosening and pulling up a little bit at a time. Now you can adjust it by 9 lengths, like say every 10 centimetres, but I'm not interested in that. It makes it a little bit easier to plot, but we're just primarily interested in getting a good set of data. So I'm just going to be adjusting it at random lengths. You just have to be careful when you're plotting the data. So we've got our small mass on the end of the pendulum here. From pendulum theory, we should know that the mass doesn't affect the period of pendulum. And what else is about set up? I've got it oriented as vertically as I can to prevent as much rubbing as possible, to reduce the amount of rubbing, that's a better way of saying it, of the string right at the base of the blocks. If it's on a slight angle, it could touch the underside of the blocks a little bit. What else is important? I'll just demonstrate that. Actually, if it was like this, as I saw some of you doing, it can rub very, very strongly. So that's why we're keeping it this way. Hopefully that's tight enough. As I swing the pendulum, I don't want to get this sort of thing going on where it's going around. Okay, that's a conical pendulum, and that has a different way of analysing it and different equations to represent the motion. So I want to try and keep it in a single plane of swing, and I'm going to start it swinging and observe it before I start measuring, just to make sure that it's going nicely. And this one is going nicely, so I think I'll take a set of results. I'm going to do a countdown so I get the start accurate. I'm going to go, and 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was 14.25 seconds. We'll write that down as our length one. 14.25. I won't record the whole process, we'll just record the first readings. We haven't measured the length yet, but we still need to do that again because we're repeating and averaging. One of the things that recording 10 swings does, there's a small amount of error as I start and as I stop the stopwatch, so I might just be a little bit off in my timing. If I'm recording a single swing, that time that I'm out at the start and at the end will compound a lot more. If I'm dividing that start and stop over the whole 10, that error is divided out when I divide to find a single time period on my average, on my single, that is. So let's do this again, and then I'll measure the length. Actually, I'll do it 2 more times. Reset. Get it swinging again. Okay, I'm not starting from out here. The pendulum theory is only for small angles, so small oscillations. That's looking good. Look at it in line, because then you can see how much side-to-side movement there is. There's none. And I'm just going to count down 2, 1 this time. Ready? And 2, 1, go. 1, 2, 3, and you could just do 4 or 5, 6, 7, 8, 9, 10. So 14.06. Let's do one more. This one's looking just a little bit wild. I'm not happy with that, so I'm going to bring it back a little bit and try again. That looks better. And 2, 1, go. 1, 2, 3, 4, 5 probably would have been better because it's long. 6, 7, 8, 9, 10. 14.03. So my first one may have been out a little bit. Okay. Oh, how did I get? Oh, right, I copied the previous one. Very easy to make mistakes. Very easy. Length measurement we need, you can perform the average calculation for the average of those 3 measurements. If I got one that said, say, 15, or 15 point something, or one that said 13 or 12, I would have thought there would be one, I might have miscounted the amount of swings by 1. Okay, but because all of these are roughly the same, it means I've been consistent with my counting. So, how do I measure the length? There's a couple of ways we can do it. We can have it while it's sitting in place like that. I'm going to measure the entire length down to the bottom of the mass, not to the centre of mass of the mass. I'm not sure whether it matters at this point, so I'll just be wary of a systematic error in my graph, which might be shown up as the line slightly higher or lower because of my measurement being off. But as long as I'm consistent and I've stated in my method where I've been measuring from, that will be fine. So at eye level, which way around does our ruler go? Starts at 0 here. This is going to be very tricky, so I'm going to modify my technique. I'm going to draw in red whiteboard marker here. Oops, let that out. And I'm going to take this out and lay it down against the ruler. I think that's going to be a more consistent way to get the reading than trying to get it while it's hanging there and looking at it at eye level. And I'll state that in my method as well. Okay, top of the red where I was there, all the way down to this one. We can only measure to the nearest millimetre, you can't go to half millimetres, and that would be a little bit over the top in any case. This is 49 centimetres, 497 millimetres, which is 0.497 metres. Okay. I'm thinking that might be a little bit too high accuracy, but that's fine. We'll write it down exactly as it appears on there, and then we can worry about whether we're trying to be too accurate later. We can discuss that in our discussion at the end. Okay, so that's how you record data, that's how you set it up. There's some important things to think about. Yeah, thanks.